I'm probably looking at the quiz again. Next week with what we have. I'm probably looking at the quiz again, but take special note of what a complement is. To know what a complement is, first we must define what the universe is, or the sample space. The sample space. Here is an example. Let's break away from the typical coin flipping scenario. The sample space for rolling a fair die is we could have a possible 1, we could have possible 2, we could have possible 3, possible 4, possible 5, possible 6. That's our sample space. Our empirical assignment, well, let me not throw the empirical, even though they call it empirical probability. Don't confuse that with the empirical rule, the 95-68 rule. But anyway, so our probability is going to be an event that rolling an even number. So out of this sample space, an even number would be 2, 4, and 6, not counting 1, 3, and 5. Roll 8. So that would be out of there. So it would be 3 out of 6, right? Which is a half. Roll a number less than 3. Less than 3 would be not tree, because it's less than tree. It's not less than or equal to tree. It's less than 3, so that only includes 2. 1. So there's 2 out of 6, so 2 out of 6 is 1/3 probability right there. So now we want to understand the idea of a complement. We've established our complements. We established our sample space. The complement signified right here, A complement, probability of A complement would be 1 minus the probability of A. Okay? And we're talking from our sample space. So the complement of rolling less than 3 would be rolling greater than 3, greater than or equal to 3, which would be 3, 4, 5, 6. That's the complement. Okay? Again, here's your basic probability, number of outcomes in what you're trying to take the probability of divided by number of all possible outcomes, as was mentioned before. And I can't remember who did that. I wish I could give you the props. But anyway. All right. Okay. You see the difference? Here's some more example theoretical versus empirical. I'm going to try to add on to this as we go through, so we can capture this part of week 3, and hopefully do a wrap up next week with what we have. I'm probably looking at the quiz again. Next week with what we have. I'm probably looking at the quiz again, but take special note of what a complement is. To know what a complement is, first we must define what the universe is, or the sample space. The sample space. Here is an example. Let's break away from the typical coin flipping scenario. The sample space for rolling a fair die is that we can have a possible 1, we can have possible 2, we can have possible 3, possible 4, possible 5, possible 6. That's our sample space. Our empirical assignment, let me not throw the empirical, even though they call it empirical probability. Don't confuse that with the empirical rule, the 95-68 rule. But anyway, so our probability is going to be an event that rolling an even number. So out of this sample space, an even number would be 2, 4, and 6. not counting 1, tree, and 5. Roll a, so that would be out of there, so it would be 3 out of 6, right? Which is a half. Roll a number less than 3. Less than 3 would be not tree, because it's less than tree. It's not less than or equal to tree. It's less than 3, so that only includes 2. 1. So there's 2 out of 6, so 2 out of 6 is 1/3 probability right there. So now we want to understand the idea of a complement. We've established our complements. We established our sample space. The complement signified right here, A complement, probability of A complement would be 1 minus the probability of A. Okay? So we're talking from our sample space. So the complement of rolling less than 3 would be rolling greater than 3, greater than or equal to 3, which would be tree, 4, 5, 6. That's the complement. Okay?
Tree, 4, 5.
Again, here's your basic probability number of outcomes in what you're trying to take the probability of divided by number of all possible outcomes, as was mentioned before. And I can't remember who did that. I wish I could give you the props. But anyway. Then we'll get into and statements. And statements. It's the lady in the pink and the dude in the hat, in the Indiana Jones hat. That's and. That's including both of these. Or is including only the lady in the pink or the dude in the Indiana Jones hat. Or.
So we will pick this up, also get into mutually exclusive concepts in the next,
There's 1, 2, 3, 4, 5, 6
videos.
They got 3.
Which we will use.
Because it would be only the pink lady, the lady in pink, and the.
Which we will use.
I guess that's.
So that's what we're at. So like, yeah, you can do your histograms in the Excel, but it's a little bit challenging. But StatCrunch is probably better for these things. But Excel's good for sorting. But it's also good for two-way tables. And I'll show you what that is all about.
Okay, so this was taking apart this two-way table we have right here. And I'll use Desmos, and then I'll show you a great way to, if you're only given like this part, I'll show you an easy way to get it into bring up Excel. There we go. And I just copied that over here. So see, we've got, so what you're going to experience there is this right here, where you're only given a table that it doesn't have a total. So in this bottom row here, let's just do totals.
If you're in Excel, you would type into Excel cobwebs from my brain here.
Let me make sure all of that is on 18. Okay, so now we just want to sum. Now use the asterisk. Sum, and then that's your function.
Not the asterisk, the at symbol, and then sum.
The beginning.
That'll total them out.
So
once you get,
notice I got.
Once you know it, you'd be able to zoom through these two-way tables like this.
I should be able to drag this over this way.
This is like copied and pasted from PowerPoint in there, and it.
Okay, so what are we going to do? We're just going to do some comparative stuff. I'll see if I can do something on the fly to make something about these probabilities. One thing we're going to notice here is we want to find the person is, okay, see keyword here, random. Keyword random. That is the basis. That is the essence of any sample. If anybody, if you look at it as poll, and you say, well, they must not interview this particular group of people, they must only interview this group of people. That's why it says, the poll said, well, if that is the case, then that's not they're not a legitimate statistical company. If they're not drawing a sample in a random sense, they are not a statistical company, and they should not be claiming to be one. Anyway, let's do happy and agree from the two-way table. What that means is that we know that happy and agree is 242. Happy and agree is 242. So the probability of happy and agree out of a big total there. Alright? That's what we should get here. Let's go back and look at the next slide. We want to access, but right now we'll stop that.
We just showed this, the agree and happy. What we're doing next is this part right here. And that is when happy or agree, they're not mutually exclusive, right? Because you obviously have some agrees and happies, right? So you can't separate them out. All right. And I was trying to figure out what was going on over here. I've seen this before, but let me tell you, I just like following the equation. To be honest, just go with the equation that we have here, and that's what I'm going to do right now. And I'm going to use the Desmos. It's the Desmos Notebook, and it'll allow us to type as well as make calculations. So let's see what we're going to do here. First, let's assign some variables. In this case, you could either agree, disagree, or you don't know, and I'm going to allow that to be K. So I'm just going to put these over here, and we're just going to type that and establish that that is the universe, right? Which is the sample space, right? Sample space, because that's all you can do out of this group. You either agree, you don't know, or you disagree. And this bottom row would total up to all the participants in the study. So let's go ahead and assign some variables. Judging from the table, agree equals 287. All right, so we've got that assignment. Now let's count up I need to make expressions. I need to count up the disagrees. And there's the disagrees right there. It's talking about A union B is equal to A plus B. Well, let's It's A intersect. I guess we'll just have to say A and D. Right? That's the equation we're working with here. So, and we can put, so like I was saying, so this is just counting sets, cardinality of sets. Now we can change it into probabilities. And just for clarity, let's go ahead and use or. So remember those symbols, the intersection and that one right there. So this is kind of like a composition function, right? When you put one function inside of another function, that Leonardo DiCaprio movie, Dream Within a Dream, just Inception. I was gonna say Deception, but it was actually Inception. So we would have to take these out right here. Notice we're not considering the don't knows right now. We don't consider that. So that's what we're going for eventually. But let's hold on to that idea real quick here. What we have established what the universe is. So like in number form, let's try this. The universe would be the set that contains the values at the bottom of our table here. The agree don't know, so it would be 287. Let me make it in order, but anyway, that's the K, and I'm going to go back here. The disagree is 764. So that we would have this set as our universe. So before we get to here, I just want to bring up this idea here of a complement. Oh, we got to enter an expression of a complement, okay? A complement is 1 minus A, right? But remember, we can do the probability stuff. So the probability of a complement would be 1, which, by the way, in our particular case, well, let's just hold on to that. Let's put the probability here, and we have that. Okay. So before we get to there, well, let's go ahead and do it. So the probability of a complement would be 1 minus the probability of A. And that's the probability of agree, which would be 287. 287 over the 1146. So we got that value right there. That's the complement, 1 minus that. Notice that that's the same thing as 1146 over 1146, right? We got the same thing that way. So that's the probability of the complement, right? And so notice that the probability of A is 287 over 1146, right? See if it'll give me a, probably not because of this. Probably got to calculate it and then I can put that in. So there we go, 25. Let's get rid of this so we can look at it. That's the complement up there. Notice what we have. It's the same thing as 1 minus 0.25. 0.4363002. We get the same value, right? Anyway, that's the complement explained. And we can explain that with the two-way table. Now, the next thing I want to go over is this equation right here. This equation right here. Okay. So that's what we put in up here. Let's see if we can, I can move this down. This is a really good program, by the way. If you want to show work for anything. Just doesn't like some of the nomenclature. Anyway, this is the one we're talking about here. So probably we want to find A or D. But notice we just found the probability of A, right? So that's the probability of A. The probability of D should be 991. So that's all the happies. That's it. So 991. That's all the happies. That's all the agrees. So what we need to do is both happy and agree. And that's right here. That's the happy and agree. That's the part we can't separate out. So what we'll do, we will just separate out the probability there. And let's double check our numbers. And that's what they got right there. So that works. And we also just proved this has a special name. I guess you could just say it the union law, but it shows up a lot in set theory as well. But anyway, that's what we got. That took us through that. And we're good to go. I should have looked at my notes. But anyway, we ended up getting it done there. All right.